something called side chain halogenation. So we are discussing something called side chain halogenation. So you have to write down the product. What will be the product in this case? So if you treat PHCH3 with Cl2 in UV light, what product do you expect? Give me any answer. Now you see, if you see this ring, you have a hydrogen here. You have a hydrogen here, so these are hydrogen in the benzene ring. And here I also have a hydrogen. Now I have an option. Either I can, basically this is, everybody can agree that Cl will replace, hydrogen will replaced by Cl dot. You see, this is a radical mechanism we'll discuss. So now I have two options. Either I can remove this hydrogen, replace with hydrogen, chlorine, or I can remove this one and replace with chlorine. Okay, so if I replace this one first, I will get CH2 dot. Are you getting out of this radical mechanism? If I try to replace this hydrogen or this hydrogen, CH3, then let us say this hydrogen, I will have CH2 dot. Now this is a benzylic radical, a stable. So this is benzylic. And this is a stable. Did you agree or not? So this is a stable, but this is not so stable. So this is not in resonance. So this is in resonance. And that's why, due to resonance, I will form the benzylic radical. So this means, that's why this is called side chain halogenation. I will add Cl here. So what will be the product? I will have a product something like this. CH2Cl, that is a side chain. I am halogenating not in the benzene ring, I am halogenating in the side chain. If you want to do halogenation in the benzene ring, you have to take AlCl3Cl2 or AlCl3Br2, or you can have FeBr2. So that is a halogenation of benzene ring. Benzene ring halogenate only in the presence of Br plus Cl plus, that is electrophile. It cannot be halogenated by the radical. Are you getting or not? And that's why if Cl dot, that is a radical, it can halogenate only to the side chain. In the side chain, even in the benzylic position, because there you have Cl dot, that is a resonance stabilized. Are you getting? So let us copy this one and then we will discuss the mechanism for this reaction. Okay, so let us come to the mechanism part. What mechanism you expect? Radical mechanism, because UV light is used, heating is required, so mechanism will be radical. Now you can write yourself. First step will be chain initiation step. You generate Cl dot. Next step, chain propagation step. Cl dot will take a hydrogen, so that is hydrogen abstraction step. So you abstract an hydrogen. In the next step, you react with chlorine and then you will add Cl dot. So finally we'll have CH2Cl. So let us write down the mechanism. Let me give 30 seconds. Okay, let us see the solution. What we can do is, first step, I can generate a radical. Cl2 will dissociate and it will form Cl dot. Now this Cl dot, that is the first chain initiation step, this Cl dot will abstract an hydrogen from PHCH3 and it will form something like HCl and CH2 dot. Are you getting? Now the third step, this will abstract a chlorine from Cl2 from here. This will abstract a chlorine from here and then it will form CH2Cl. In the second step you see this electron, one electron goes here, one electron goes here. So you will have a bond here. So this hydrogen is abstracted. So you will have HCl here and then CH2 dot. So these two steps are basically propagation step. You see the first step is initiation and 2-3 step is called propagation step. You can copy this one. And now this Cl dot basically we have regenerated. So initially we have Cl dot that is regenerated. So here I have Cl dot that is used in the second step, and now Cl dot is regenerated. So now these two steps can basically go again and again, and that's why this is a propagation step. Are you getting? Now if you want, you can write a resonating structure of this benzylic radical also, because this benzylic radical is resonance stabilized, and that's why chlorination happens at benzylic position. So you can write the resonating structure. I will already written these resonating structures. So you can write resonating structure for benzylic radical, something like this. Are you getting? So let us copy this one. So we will get these are the possible resonating structure for benzylic radical. So you can do yourself. So what you have to do is first time flow 1 electron this side, 1 electron this side, you will get this. Next you flow 2 electron, 1 electron this side, 1 electron this side, you will get this. Are you getting? So if you flow 1 electron this side, 1 electron this side, you will get this, and consecutively you can do this one. I assume that you understand whatever we are saying. And last thing, generally in this case what I have done is I have added one CH2Cl. This can be also done dichlorination, so you can abstract even more hydrogen. If the Cl2 is in excess, you can do dichlorination, you can do trichlorination. So chlorination, dichlorinated and trichlorinated product are also possible. It depends upon the concentration of Cl2. If the concentration of Cl2 is low, I will have monochlorinated product. If the concentration of Cl2 is high, I will have trichlorinated product. Are you getting? So dichlorinated and trichlorinated product are also possible in this reaction. So let us copy all this and then we will go for the next problem. Okay, let us finish it here and let us go for the next problem. Have you written or not? Not yet. Something missing on the top. Okay, let us see once again. If you missed something, let us copy. Okay, let us go for the next problem.